Okay, we're going to go ahead and now begin talking about type 2 naming. So please make sure you have the Zoom up with my screen shared so that you can see the steps that we have to work through. Okay, so with type 1 metals, because there is always the same ion that is formed, we don't need to specify anything more than the name of the metal when we name the compound. So for example, if we have something like a formula of NaCl, because sodium is type 1 and it always forms a +1 charge, we don't need to tell the person who's looking at this any more information than the fact that we are dealing with sodium metal, and then the nonmetal is chlorine, which changes to chloride. Okay, so with type 1, that's all you have to do. But with a type 2 metal, and those are our metals that are down in that middle section of the periodic table, they can form more than one charge. So we need to specify which particular ion is part of our compound. So for example, if we were dealing with CuCl, we can't just write copper and then chloride, because copper can have a couple of possible charges. Copper could actually be +1, +2. It could have other possibilities. So for that reason, we need to add some information to our name to tell the person who is looking at that name which copper ion we're dealing with. And that is going to be in the form of a Roman numeral. Okay, so we are going to learn how to figure out what the Roman numeral is based on the formula. And then this needs to apply to any time you have a type 2 metal in your formula. Just in case you forget, the type 2s on this page are all the things that are in green. Okay, so these are any metals that aren't in group 1 and 2, or silver, zinc, and aluminum, because those have specific charges. Okay, and again, we don't know the charges of those compounds just by looking at the periodic table. So how then can we figure out the charge if we can't go to the periodic table and look for it? Well, luckily, we can use some other information that's part of our chemical formula to figure that out. So I'm going to show you a video. This is a very good video. This is going to show you how we go about figuring out the charge. So please watch closely.
This is an introduction to naming ionic compounds with transition metals. The transition metals are the elements in this part of the periodic table. And when we write the name for an ionic compound that contains transition metals, those names usually...
Are you on Zoom? Are you on the shared screen? Oh, you guys don't see it? Hold on. That's weird. You see it now? You see the video? Still loading for some of you.
have Roman numerals in the middle of them. So in this video, we'll learn how to take the formula for a compound that contains a transition metal and how to write the name for it with Roman numerals and everything. So transition metals. The transition metals are the elements in this part of the periodic table here, and I've written in some of the most common. I'm also going to be talking about some of the metals over here, which aren't technically transition metals, but they act a lot like them. These metals are unique because many of them are able to make multiple ions with different charges. So iron, Fe, for example, is able to make an Fe2+ ion, but it's also able to make an Fe3+ ion. Okay, this is different from the metals, say, over here, that tend to always make ions with the same charge. Sodium, for example, is in this +1 column here. And so when sodium is in an ionic compound, it always makes an ion with a 1+ charge. Magnesium here is in this 2+ column, so when it is in an ionic compound, it makes a 2+ ion. But the transition metals can make a wide variety of different ions with different charges. Some of them can even make 4 or 5 different ions, each with a different charge. So these different charges on transition metals really come into play when we want to name a compound that contains a transition metal. So here we have FeCl3, and for the Fe, the iron, we can't tell right away, just by looking at this, whether the Fe is Fe2+ or whether it's Fe3+, right? We have these two different types of ions that Fe can make. Now, we can distinguish between these two ions by using Roman numerals to give them different names. So the Fe2+ ion, we call that iron 2, with the Roman numeral for 2 in parentheses. The Fe3+ ion, we call that iron 3, with the Roman numeral for 3 in parentheses. And we'll use these ion names when we want to name the whole compound. So if the Fe here turns out to be Fe2+, we'll call this compound iron 2 chloride. And if this iron is iron 3+, we will call the compound iron 3 chloride. So in order to figure out whether we're talking about iron 2 chloride or iron 3 chloride here, we got to do a little bit of math and work backwards to figure out which of these two charges iron has in this particular compound. Let me show you how to do it. So to find the charge of a transition metal, we start by focusing on the ion with a charge that we do know, that's certain, that's not going to change. And for this, that's going to be Cl.
Okay, just a quick clarification here. And every single one of these that you do, that you have a type 2 metal, the ion that we're going to start with to figure out the charge is always the second part. Okay, so whether it's an element like chlorine or a polyatomic ion, that is the one that we're going to look up the charge for, because our negative ion, which is the second part, we always can figure out the charge from either the periodic table or as a polyatomic ion. And I'll show you that when we do some examples.
Cl is in this column here on the periodic table, so that we know that in an ionic compound, Cl always makes an ion with a 1- charge. Okay, so we've got Cl1-. Now, how much total negative charge do we have here? We have 3 Cls, so that's going to be 1, 2, 3. And since we have 3 of them, the total amount of negative charge is going to be 3-. Now, in an ionic compound, the negative charge always has to balance out with a positive charge. So if we have 3- on this side, we've got to have 3+ on this side. So what's the charge on iron now? Well, there is 1 iron ion in this compound, which means that all of the positive charge has to be on this 1 ion, which means that its charge is Fe3+. Okay? So 1 ion of Fe3+ gives us 3+ of charge, which has to be balanced out by the 3- over here, which is distributed over the 3 Cl-. So that's how we figure out the charge on iron. And since this is iron 3+, the name for this compound is going to be iron 3. And then for Cl, when chlorine becomes a negative ion, we call it chloride. The IDE usually gets added to the name of an element when it becomes a negative ion. So chloride is what we call Cl1-. So iron 3 chloride is the name of this compound. We had to work backwards and figure out the charge of iron, and then we can call it iron 3. So if you want to get really good at naming compounds with transition metals and using the Roman numerals and all that, you've just got to get a lot of practice. So I've made another video that's just a whole bunch of practice problems on naming ionic compounds with transition metals. But before you check that out, I want to talk about a couple of important things. The first thing I want to talk about is when we use Roman numerals for naming and when we don't. This confuses a lot of students, okay? So when do we use Roman numerals? Well, we use Roman numerals when we're naming compounds that contain transition metals. So here are 3 compounds that contain transition metals, and as you can see, we use these Roman numerals. And we use the Roman numerals because copper, iron, and vanadium are transition metals, which means that they can make multiple ions with different charges. So we kind of need to pin down the specific ion that we're talking about in each one of these compounds, right? So we put this 1 here to say we're talking about copper 1+, because copper could make other ions. We're talking about iron 3+ here. We're talking about vanadium 4+, because they could be a variety of different ions. Now, on the other hand, we don't use Roman numerals when we're naming compounds that don't contain transition metals, that contain, for example, the metals over here. Take potassium iodide, for example. Potassium, K, is in this column. It's in the 1+ column, which means that in an ionic compound, potassium always makes an ion with a 1+ charge. That's the only choice. It can only be 1+. So we don't need to put a Roman numeral in there to specify that it's 1+, because that's the only choice that it could be.
Okay, he just goes on with more examples. Okay, also don't forget that we also have zinc and silver and aluminum over here that are single charge ions. Okay, but if you're using your colored periodic table, then it should be pretty evident at this point what a type 1 versus a type 2 metal is. Okay, so let's do just a little bit more practice before I set you off to do your own work. Okay, so here is an example. And I'm going to show you an alternate method to do this as well, in addition to the way he does it, okay, because some of you will be able to do these better in your head if I show you this other method. Okay, but don't forget, you're always welcome to use scratch paper as you work through these. Okay, so step 1, when you have a formula, when you have the element symbols and subscripts, is to look at your first element and say, hey, is this a type 1 metal or a type 2 metal? If it's a type 1, you don't need a Roman numeral. If it's a type 2, you do need a Roman numeral. So we'll look up manganese, and we will see that manganese is in fact in the middle section of the periodic table here. Okay, and it would be colored as a type 2 on your colored document. So type 2 means Roman numeral. We're going to have to figure out what the charge is on that manganese in order to write the correct Roman numeral. But before we even do that, we can figure out what the name is. We're just going to leave a space for that Roman numeral, okay? Because the rest of the naming is still the same. You name your metal, so it's going to be manganese. I'm going to put a set of parentheses here because we have to figure out that Roman numeral yet. And then we name the second part, which is oxygen. And because it is a single element that's an anion, we're going to change that to oxide. So this is going to be manganese, some Roman numeral, and then oxide. But we're going to figure out now what this Roman numeral is. Okay, so using the method that he showed, I'm going to rewrite this here. Remember that to figure out the charge of the metal, you have to work backwards. And we always start with the second part of the compound because we know that charge. In this case, we're dealing with oxygen, and oxygen's an element. So you would go to your periodic table, you would find oxygen, and on your colored periodic table, you would see that that has a -2 charge. So I'm going to rewrite O -2 here. And this subscript tells me that we have 2 of those in the compound. That means we have a total -4 charge, which means that we have to have a total of a +4 in that entire compound to balance that out. Well, how many MNs are in this compound? There's no subscript here, which means that it's just 1. So we have 1 Mn ion and a total +4 charge. So that means all of that +4 has to come from that single manganese ion. And now that charge that we wrote there tells us the Roman numeral, which would be IV. Okay, so this would be manganese 4 oxide. Another way to do this without writing all of the ions out, I'm going to rewrite my formula. And this is how I usually do these, is I start by thinking about my negative charge. I'm just going to write that up here in the corner. Okay. Now, we know that 1 oxygen has a -2 charge, but we have 2 of those. So if we multiply those, we know that there's a total -4 charge. I know on the other side then on the metal, there has to be a +4 charge. And again, if we take the subscript, which in this case is 1, and we multiply it by our positive charge, which we don't know, 1 times 4 or times something has to equal +4, which gives us a +4 charge there, okay? If that completely didn't make sense to you, don't worry about it. You can use this other method. It's just that it's a little easier to visualize it without doing scratch work that way. Okay, let's do another example. Okay, forgot to put my parentheses in here. This time we have a compound that has a polyatomic ion in it, okay, but that's really not going to be any different than when we had a type 1, okay? We're still going to name that part the same. So let's work through the process on this one. So first thing you do, look at your first element and see if it's a type 1 or a type 2 metal. Copper is in our middle section here. So it is a type 2, which means we're going to need a Roman numeral, okay? We're going to name it and leave a space for that Roman numeral. We have copper, some Roman numeral, which we're going to figure out, and then we have a polyatomic ion this time. So when you look that up on your sheet, you will just see that it is sulfate. So we simply name the polyatomic ion. Now we need to work backwards to figure out the charge. Here, the second half of our compound is not an element, but we can still use that to find the charge. Instead of going to the periodic table and looking up the charge, we have our polyatomic ion list, and we know the charges of all our polyatomic ions. So here we have sulfate, and sulfate as a group has a -2 charge. So I'm going to use his method here. I have my sulfate group, and it has a -2 charge. How many sulfates are in this compound? Well, there's no subscript here, so that means there's only 1 sulfate group. There it is. Our total negative charge is -2. That means our total positive charge is going to have to be +2. How many coppers do we have? Well, again, no subscript, so there's 1 copper. The total charge has to be +2. So that means our missing piece here is a 2. The copper has a +2 charge. I'm going to do one more that's just a tiny bit more difficult. I'm going to do Fe2 let's see. No, I'm going to do Cu2 CO3. Okay. Cu2CO3. So we already know that copper is a type 2, so we're going to need a Roman numeral. That means this is going to be copper, some Roman numeral, and then CO3 is carbonate. Let's work backwards. We have Cu2, CO3. So we have one carbonate group. And if you go to your polyatomic ion table, you'll see that that has a -2 charge. So there's a total, my pen is a little wonky here, a total of a -2 charge here. Now let's go to our copper. We know that the total positive charge has to be 2 so that those balance out. But how many coppers are in this formula? There's actually 2 of them. So that means we have 2 copper ions that have to add up to a total of a +2 charge. That means that a single copper is not +2, but each of these individual coppers must be +1. So in this case, our Roman numeral would be a 1 to show the charge of the copper. Okay, I know we went over that pretty quickly, but it's really just a matter of practicing them and figuring out your charges. So at this point, there is a class kick that has been assigned called Class Kick Chapter 9, Part 4. And you should be able to do page 1. So let me pull it up just so you can see what it looks like. If you've not finished part 3 yet, you need to finish that first. In this section, these are all type 2, so you will need Roman numerals. I've put in 3 different boxes, a name for the metal, the Roman numeral, and then your anion. Okay, so you can begin working through those. Now, you are welcome to use the scratch space on here or use a separate piece of paper to do your work through, but your final answer needs to go in the boxes. Okay, we will work on this tomorrow in addition to the next page. So we don't have too much time left here, but you can get started on this if you are done with part 3. Not yet. No, I have to add those, so you can't work ahead yet. Yeah, you can't go to the next page yet on this because I don't have the text box added. I'll add those momentarily though.